Hello everyone. Today we will see how to compute eigenvalues in Python. Now let's do some examples about eigenvalues using Python, and we will be using the SciPy package, and there is a linear algebra library, and we can import the EIG. Basically this is for the eigenvalue problem. We also import NumPy, which will be necessary to work with the matrices and arrays. So in this first example, we define a matrix. This is a 2 by 2 matrix. The first row is 5 and 2, and the second row we enter 2 and 3. And then simply you can call the EIG function for the eigen values and eigenvectors. It will be able to produce both of these, the eigenvalues. Since we have a 2 by 2 matrix, we will have 2 eigenvalues, and then there will also be 2 eigenvectors correspondingly. So finally, after we we call the function, then we can actually print the results on the screen. You can come up with many different numeric examples. The second example is pretty much the same. We define a matrix, 2 by 2 matrix here, and then call the EIG eigenvalue function here that will produce us the eigenvalues and the eigenvectors. So let's comment out the rest for the moment, and then let's run these first two examples. So the first two examples, the result is printed as expected. The eigenvalues for the first example is given, and then the eigenvectors are also displayed here. And similarly, for the second example with this minus 317, 921, that was our matrix, the eigenvalues are also calculated here. In both of these examples, we have real eigenvalues. As you might know, since eigenvalue problem, we are solving a polynomial equation. We can also have complex roots for the characteristic equation in the eigenvalue problem. But these two examples, we didn't have a complex root, so we have the real numbers. And the eigenvectors are also given. So as you see, the first eigenvector and then the second eigenvector is given as the first row and the second row of this output. If we look at to the remaining example here, let me uncomment it and try to run it. This is a 3 by 3 matrix this time, and similarly we use the same eigenvalue function, and since we have a 3 by 3 matrix, our characteristic root in the eigenvalue problem will be a cubic polynomial, and then we can basically we can get 3 roots from this third order polynomial, and as you see, the eigen values we obtain are given here. So these are the eigenvalues for this 3 by 3 matrix, and then this time we will have 3 eigenvectors corresponding to each eigenvalue. So this is the eigenvector that corresponds to the first eigenvalue, and then we have the second eigenvector that corresponds to the second eigenvalue, and so on. Now, alternatively, we can use symbolic computing package SymPy, SYMPY. So that's also a potential alternative. So let me comment out here. So you can see for the same problem, actually we can consider the same matrix that we did using the linear algebra SciPy package. But now, alternatively, we can use a different package to solve the same eigenvalue problem for the same matrix. And as you see here, we can first we define this SP, and then we call the matrix. So we created a symbolic representation of this matrix, and then we can call the eigenvalues method, the function here, inputting our symbolic predefined matrix A. And this will also return us the eigenvalues for this matrix. And similarly, we can use the eigenvectors method, and for using the same matrix A. And then finally, we can display these results. We can display these with some print statements. So if I run it again, we will see now. First of all, we have the eigenvalues and eigenvectors given. So as you see, this is the symbolic package computed result. And as you see, everything it's not represented just like in the previous case. For example, this was the first eigenvalue 1.29 something. But here this is represented symbolic as an expression 9/2 minus square root of 41/2. So basically it's a different representation depending on your needs. What you want to do, you can either choose the direct numeric calculation using the SciPy package here, linear algebra, or do the symbolic computation and use the SciPy package as we did in this part. So thank you for watching. See you next time.